Good morning, everybody. Today is 9th of December 2020. The day is Wednesday, and right now I am with the 11th Cambridge class. My name is Ferhan Mazher, and the subject we are studying is Physics 5054. And the main tasks today, because with my 11th Cambridge class, we are working on past papers and we are working on actually the paper 2, and it's we are working on the variant 1 because the variant 2 is also available in the red spot. So variant 1 I am trying to do with my class myself. So last time we were able to complete you know to summer 2019 to one paper, and we were working on its section B only, and we were able to do the 9 and 10 question. And 11th question was left, and today we are working on that question. So on your screen, we have the question number 11. It says the teacher carries out an experiment on radioactivity using the apparatus shown in the figure 11.1. The count rate is a measurement of the count during 1 minute. State the name of the one type of radiation detector. So
GM
the
tube.
GM tube, yes, Geiger Moller GM tube, called the GM tube. If you want to write, I can show you. Can you see this Geiger Moller spellings? GIEGER MULLER. This is 1 mark question. You only have to state. You have written this.
Yes, sir.
Okay, let's move to the next part. State one safety precaution the teacher must take when using a radioactive source. Whenever you are using a radioactive source, there can be many precautions. For example, your time of exposure to the radioactive source should be a minimum. You should keep it minimum, and the radioactive source should be always placed inside a lead box. And whenever you are using it, you should use tongs, TONGS, tongs. So these are the radio. Okay, can you see the marking scheme? Keep distance away from the source. You only have to mention one. Okay, or use absorber. Absorber is, for example, the lead is the absorber, so that should be placed in the lead box. If you want to keep it safe, you should put it in a lead box or use for short time. The It should be used for a very short time. Okay.
I have written the answer.
Okay. B part. They say the teacher that states that the emission from the radioactive source are random in time. What is meant by the random in time? Random in time means that radioactivity is a random process, and random in time means you cannot predict that at what time the sample will decay. You cannot predict it. You cannot predict that at what time this atom will decay, at what time the other atom will decay. You cannot predict which radiation will come out. You cannot predict which, not what type of radiation will come out, but you cannot predict at what time the radioactive isotope nucleus will decay. You cannot predict this. So this is a random process. Do you understand what I'm saying?
Yes.
He says the time between emissions vary, unpredictable, or different readings when repeated for same time. So if you are taking the reading from the GM tube of radiation from coming out of a sample, So if you take the readings after equal intervals of time, the reading every time will be little different from each other. So it's unpredictable. You cannot predict that how much radiation will come out. Have you written the answer?
Yes.
Okay, so what's your answer?
Radioactivity is a random process. You cannot predict which atom will decay at this particular time.
Yes. Yes. That is, the next part is describe how the apparatus is used to show that emissions are random in time. How the apparatus will show. Now that is the question. So after uh, specific periods of time for equivalent, for example, you are taking reading after 5 minutes. Okay. So after a specific time period, you are taking the reading. So every time when you will take the reading with the help of this GM tube, the reading on the GM tube will be different, a little different from each other. Okay. So this means that apparatus will show, the reading on the apparatus will show that the emission from that radioactive source is random, because every time the reading will be different. Don't write the answer. Let me check from the marking scheme also. It says repeated count for a specified time, which means mere time when count event occurs. Results not the same, not always the same. Yes, you understand? For some, you understand this idea.
No,
Two
sir.
things. You have to write two things. One thing is after every specific time, after every certain time, you are taking the reading with the help of the GM tube. That how much radiation is coming out of that source. You will find that every time the reading will be different from each other. They will never be the same. So that
Okay,
shows,
sir.
this is how the apparatus will show you that the radiation is a random process. You understand better?
Yes.
ओके, आंसर लिख लो तो फिर आगे चलते हैं.
After an interval of time, the readings on the detector will be changed. Reading will not be same at any time.
Yes, लोड हो गया. Okay, describe how the apparatus is used. This is done. This was 2 mark question. Then state what is meant by background radiation. 1 mark question. You see, around us, uh, all the time, radiation is present, and that radiation which is all the time present around us, and our bodies are have adopted to that amount of radiation. We are used to that radiation. That is known as background radiation. And the second question is what? Okay, you know that background radiation is coming out because there are a lot of there can be many sources around us. For example, there might be some minerals in the soil which we have, which are radioactive. There might be radioactive rocks beneath our soil, and there might be some radioactive waste dumped in our area or little away from our area. There might be some nuclear testing going on in our area or in our country or in even neighboring country. From there, the radiation can reach us. Some radiation is also coming out of space. That is called cosmic rays. So around us, there might not be a specific source present, but the source is present or not, but we will always have radiation around us, and our body is used to it. That radiation, which is all the time present, that is called background radiation. Another way of saying this thing is that without putting the sample in front of the GM tube. For example, you have not put the sample, radioactive sample in front of the GM tube. You open the GM tube, just open the GM tube in the open air, take a measurement. The GM tube will give you a reading of radiation, which means that without the sample, there is radiation present in the atmosphere. That reading, that radiation is called background radiation. You understand?
Yes, sir, many liquor radiation that are present all the time and our body is adapted to its exposure is called background radiation.
Okay. He says the radiation when there is no source or naturally occurring radiation or always present. So your sentences are right. Okay?
Yes.
Okay, let's move to the next one. The teacher measures the count rate due to the source. Describe how the count rate is corrected for the background radiation. So the method is very simple. Try to understand. Without sample, you switch on the GM tube and note down the background radiation. Okay? Note it down. For example, for your understanding, let's say the machine tells you that the reading of the radiation, the background radiation is 20. Then you put the sample in front of the GM tube and then you take the reading of the sample. The reading of the sample, for example, GM tube tells you that the reading is 350, for example. Now, this 350 also includes the background. Okay. So if you want to find out the reading purely, you have to do the calculation yourself. And how you will do that? From 350 minus 20. And it means 330 will be the reading of purely the radiation, purely the radiation which is coming out of the sample. Do you understand what I am saying?
Yes.
मैंने क्या बताया? What I told.
Sir, you told that to check whether टू मतलब हम लोगों को अगर रेडिएशन चाहिए मतलब एक सोर्स की हमें रेडियो रेडिएशन पता करनी है तो वी विल
हाँ,
फर्स्ट प्लेस जीएम ट्यूब विदाउट एनी सोर्स ऑफ रेडियो एक्टिव सोर्स और फिर हम
हाँ,
उसकी रीडिंग नोट कर लेंगे अगर फॉर एग्जांपल उसकी 20 है 20
हम्म,
जीएम ट्यूब पे आई ये वैल्यू तब हम लोग सोर्स जीएम ट्यूब के आगे रखेंगे और फिर हम लोगों को फॉर एग्जांपल 350 मिली है तो हम लोग जो रेडियो एक्टिव सोर्स की वैल्यू होगी ना वो 350 से माइनस करेंगे 20
हम्म,
और हम लोगों को प्योर सब्सटेंस की मिल जाएगी
ओके सही बात है अच्छा देखो लेट्स चेक इट दिस इन द मार्किंग स्कीम in the marking scheme he says that radiation when there is no source sorry Mayer count rate with no source, that's the first point, and subtract from Mayer count rate for the same time, and then with the source Mayer the count rate, and from that reading subtract the background. Okay, write this answer and then we will see what you have written. You can look at the marking scheme as well. Marking scheme is showing on your screen. We are doing the question number 11. This is summer 2019 to 1 paper. We are on the question number 11 and its second part. C and its second part. With the help of the GM tube, we will take the reading without the source, and then we will take the reading with the source, and from that second reading, we will subtract the first reading. That will give you the count rate of the sample. That's how you correct that reading. Ji Kursam, you have written?
Yes, sir.
Yes. So what you have written?
Measure count rate without any radioactive source present. Measure the value by placing source. Subtract the reading without source with the reading when source is placed.
Acha, lafaz, when you say subtract, you don't say with the reading, from the reading. Don't say with the reading. Okay? From the reading
Oh,
with the source. Okay? Otherwise, very good. Okay, Ji? We have
yes.
other. Uh, so now repeat your answer slowly so that the other, we have Manur, we have Zainab also with us. So they can also
Measure
write down.
count rate without any radioactive source present. Measure the value by placing source. Subtract the reading without source from the reading when source is placed.
Yes, that's perfect answer. These are 2 marks. You will get full marks. Should we move to the next question?
Yes.
Okay, here we go. The corrected count rate is recorded for various distances d between the source and the detector. Figure 11.2 shows a graph of the result obtained. So, do you understand what this means? This means the values of the radiation on the count rate here on the y-axis, and on the x-axis he has shown the distance between the GM tube and the source. And you see he is moving the GM tube away, 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 away. When the GM tube was just 4 centimeter away, 4.5 centimeter away, the radiation was not able to reach the GM tube. When the GM tube was 4.5 centimeter away from the source, this graph tells me the radiation was not able to reach the GM tube. So GM tube started showing zero reading. This is the, understand this thing.
Yes.
He said determine the maximum distance that the radiation travels in air. That is just 4.5. After 4.5, that radiation cannot penetrate in air. So the radiation which only penetrates
Okay. Next.
4.5 centimeter, you remember what we call that? Alpha. Alpha has that less penetration power.
Yes, few centimeters in air.
Yeah. So you see in the next part he says the state the name of radiation emitted by radioactive source and give a reason for radiation is alpha particles. And what is the reason? Because the alpha has only 4 centimeter or 5 centimeter penetration power in the air. Okay? Okay? You understand? Do you understand? Let me show you the marking scheme also so you can
जी
write the
सर
answer. So this is D first part and second part. These are the answers. 4.5 centimeter alpha hai. Range of alpha is less than 5 to 7 centimeter.
सर
Yes.
सर मैंने लिखा है अल्फा हैव पेनिट्रेशन पावर ऑफ फ्यू सेंटीमीटर्स इन एयर ये सही है
Yeah, yes. And we have number also.
ओके
You can mention a number also. Like in the marking scheme, I said the penetration power is less than 5 to 7 centimeter in air. We know this fact. So you can also mention this in your explanation. State. Okay. The next question. Ji bete, can we move? Can we move
यस
to the
सर
next part? Okay.
Yes.
As the radiation from the source travels in the air, it causes ionization. Describe what is meant by ionization of the air. You see, the alpha particles, they are like nucleus of helium. They have positive charge. Their positive charge is 2. They have 2 protons and 2 neutrons. It's purely a nucleus. And when it travels in air and it collides with the atoms which come in its path, it is able to knock out the electrons in the valence shell of those atoms. So see, when it will strike, or it will collide with the atoms which are coming in its path, and it will be knocking out electrons from their valence shells. So what will happen in the air? Positive and negative ions will be created, and this is called ionization. You understand? You understand this thing, this idea? You are studying chemistry also, na? Because this idea is also in the chemistry. Air atom molecules lose gain electrons to become ions. So the basic thing is when it travels in the air, the alpha particles, they have positive charge and they are like nucleus of helium. So when they collide with the other atoms of air, so what happens? They knock out electrons from them and they convert them into their ions. So this is called ionization. Positive and negative ions are created in the air when they are traveling. Kusam, if you have written your answer,
Sir,
we would like to, yeah.
when radiation travels in air, when radiation travel in air,
Uh,
they collide with the particles. This cause gain or loss of electrons.
it knock out electrons and ions are created, okay? Yeah. Oh. Okay, so here a graph, 3 mark question graph is given. It says the half life of another radioactive source is 40 minutes. The half life, Zainab server is with us and she is saying that the network is having issue. So it's a normal thing in Pakistan that the network has issue. We will be recording. We are recording this, and if you use, oh, it's raining there. If you will log in by your Beaconite email ID, you will be able to see it. Okay, so don't worry, because we are recording this, so we will send you the recording. There is no problem. Enjoy the rain. The half-life of another radioactive source is 40 minutes. Initially, the corrected count rate from this source is 300 counts per minute. On figure 11.3, plot a suitable points and draw a graph of the corrected count rate as it changes with time. Okay, so let me open the snipping tools and we will copy this thing from here. Let me copy this. Take it to the. So the 40-minute is the. Let me open the paint. And we work with that. Okay, bete. Now we have to draw a graph of the half-life. You know, after one half-life, the count rate will drop to half. So let me draw this with blue color. So let me increase the weighting. So the first point is that when the time is 0, the reading is
300.
the reading is 300. So mark a point here, okay, at 300. After 40 minutes, the
150 हो
value will
जाएगा.
have, the reading will have, and it will become how much?
150.
Yeah, it will become at a 150. This is the point. Let me draw a cross here. I'm trying to draw. Okay. After another 40 minutes, the 150 will further have. When the
75.
150 has, it becomes 75. Okay. So at 80, it will be something like 75. It is between 100 and 50. It will. I am working on this on oh, okay, something here. Okay. So another 40 minutes will pass, the 75 will have. So what is the half of 75?
32.5.
How much?
32.5.
No. Half of 75. You don't have a calculator?
37.5.
Yes. Now you are talking. 37. 37 will be here somewhere, okay? Here. Here. Okay? Now I will join them with a freehand. Okay, I might not be able to draw very good because I'm working in the paint, but if you are working with the freehand, you have to draw them with a curve. So I will try to be. Oh, you see, the graph should not be like this, but I'm working with the mouse, that's why my hand is shaking. That's not a very smooth curve, but you draw with your pencil, so draw it very smoothly, okay? It just to describe you how, demonstrate you how to do this. Kursam kindly and Manur also. Manur, do you have your booklet in front of you?
जी सर.
Okay, so draw this graph, bete.
Okay.
Sir, made.
You are done?
Yes. नेक्स्ट अब कौन सा पास्ट पेपर करना है?
अभी 2018 winter 2 month show करेंगे. So beta, this section B is done. Manur, when you are also done, so let us know.
सर चले आगे.
Okay, now we will open another paper. Let me open the paper. Now we will work on winter 2018 2-1 paper.
Sir, when we will work on section A?
Section A, I have already worked. I just need to post the
When?
video.
Okay.
If you want, we can post it this weekend. I will post. Okay. So for these working days, I have assigned you paper 1.
On weekends, you can give us section A
Uh,
videos on Google
we have
Classroom.
done 2 papers. Now in the online class, we have done winter 2019 2-1 and summer 2019 2-1. There's
Yes.
section B we have done. So section A, we have video on them. So I will send you. I will post it in the Google Classroom and in your class also. So you can
Okay.
write them in your copies and you can also understand because that is a recorded video. Okay. Oh, so bye bye. Acha. So if you are open this paper better now in your booklets. October, November 2018 to 1.
Opened.
Okay. We will be working on its section B. I'm opening its marking scheme also and go to the section B. Okay, now we are working on the October, November 2018 2-1 paper, it's a theory paper, and we will be only working on its section B. Okay, let me go to the section B and we will start solving the question. Where is the section? Okay, here we go. Okay, D. Section B. Winter 2018, 2-1 paper, section B. A bucket of water is pulled up out of a well using a rope. Figure 8.1 shows the rope winding onto a cylinder as the handle is turned. The empty bucket has a mass of 1.0 kg. Complete the sentences that describe mass by filling in the gaps. The mass of a body is a measure of the amount of dash in the body.
Matter.
Is the amount of
Matter.
matter. Yes, amount of matter. It resists a change in the state of dash of the body. The mass resists the change of state of motion. That is called inertia. It always resists the change in the state of motion, state of rest, we can say. Normally we say it it resists the any change in the state of motion. Where is that go? Yeah. You can use either, you can see both the words we use. Inertia is basically, or mass is the resistance to any change in the state of motion, or if the body is at rest, then you can use the word rest also. Have you written this?
Yes.
Okay. The next question is, when the bucket is full, it contains 2.4 expo minus 2 meter cube of water. The gravitational field strength G is equals to 10 Newton per kg. Explain what is meant by a gravitational field. Gravitational field is a space or area around a object where where other objects experience its force of gravity. For example, around the Earth, the space in which other objects will experience the force of gravity of the Earth. That space, that region around the Earth is known as gravitational field. Let me show you the definition also from here. This is a, you see here, a region of space where a mass experiences a force due to the gravitational attraction. Write this definition.
Sir, next.
What you wrote?
It is an area in which it is an area in which a mass experiences force due to gravitational attraction.
Yes. Next question is, the density of the water is 1000 kg per meter cube. Determine the total weight of the bucket and the water. He says the density of the water is this. The volume of the water is given. You can see this. Eh? So first of all, find the mass of the water. Okay. So let me do this. You will do. You will be able to do this.
Yes.
Okay. You know the mass is, sorry. What we want to find out the, first of all, mass of water. The water only. Okay. So you have its density. You just multiply it with the volume. Kusam, you have a calculator? You have a calculator?
Yes. Yes.
Density is 1000 and multiplied with, and the volume is given. That is 2.4 expo minus 2. 2.4, 2.4 expo minus 2. Okay. Just do this calculation in your calculator and give us the answer.
24.
What is the answer?
24 kilograms.
24 kg. That's the answer. Okay. Now, the mass of the empty bucket is how much? It is given in the
1
question.
kilogram. 1 kilogram.
That's 1 kg. Yeah. So the total mass will be,
25.
so 24 plus 1, 25 kg. So what will be the weight? You know the weight
250.
is equals to mg. That's the formula. So it will be
25 multiplied
25
by 10.
multiplied 10. So the answer will be 250 Newton. Do you understand?
Yes.
Okay. Manu, do you understand?
जी सर.
Okay. So you can see this is the marking and this is that part. I'm showing you the marking scheme. So this is how it is done. Okay. Okay. Let's do the next one. It was a 3-mark question. Okay. So see this how important this is. Okay. This one. The radius of the cylinder is 0.12 meter and the handle is 0.40 meter from the axle of the cylinder. The weight of the bucket and the water produces a moment that acts on the cylinder. Calculate that cylinder. Calculate that moment. Okay, let me show you this. So this bucket is acting here. The weight of the bucket is here. Bucket and water. How much is that weight? 250 Newton. And the perpendicular distance from the point to pivot, that is the center of, or the axle, the center of that cylinder, that is the pivot. So its perpendicular distance the weight is acting here. The weight is acting here. So its perpendicular distance from the axle is this much, 0.12 meter. So the moment produced is equals to force multiply the perpendicular distance from the pivot. The force multiply the perpendicular distance between the force and the pivot.
30 is
So,
the answer.
so you multiply 250 with 0.12 meter. You write the formula that moment is equals to force multiply perpendicular distance between the force and the pivot, and then you will get the answer. Just put the values. 250 multiplies 0.12 meter. What's the answer? Kursam, what you said?
30 nm.
So 250 multiplies 0.12 and the answer will be 30 Newton meter. Is this what you got?
Yes, sir.
Okay. The next part. Calculate the minimum force on the handle that balances that moment. You see, to balance that moment, you are providing force here at the handle. The handle is in your hand. Okay. So with your hand, you are also supposed to produce that much moment. You said 13 Newton meter, huh? So that much moment should be produced by this handle also. So then the thing will be balanced. Now the moment arm of the handle is 0.40 meter. This much. From the pivot, how much is this distance? You will apply force here at the handle. We want to calculate that force. So F multiply distance will be equals to the moment. Moment we already know the moment, the minimum moment you should produce is 30 Newton meter. So moment is equals to F multiply D. Moment is 30. The D is 0.40 and F is question. Okay. Will you be able to find out the force?
75 Newton.
75 Newton. Let me check. Yes, ma'am. 75 Newton. Manur, are you done with this? Manur?
जी सर जी सर
Okay, okay, okay. Good, okay. Very good, very good. Okay. So this is done. Okay, the next part. A farmer pulls the bucket of water up at a constant speed. He needs to exert a force on the handle that is greater than the calculated in the C second part. He notices that there is a slight increase in temperature where the axle is in contact with the frame holding it. So there's two reasons why the force exerted is greater than the value calculated. The
To
force,
overcome friction.
yes, whenever you say friction, you also have to mention friction between which parts.
और
Okay, it's
दूसरा
very important.
हीट वाला.
Yeah, this is the answer. Friction between the axle and the cylinder, because there is friction between the axle and the cylinder. You also have to raise the weight of the rope, and the force which we have applied might not be perpendicular to the perpendicular. Rope wraps over itself and increases movement. Because when the
सर मुझे
rope will,
दूसरा पॉइंट नहीं समझ आया.
which one?
मुझे फ्रिक्शन वाला तो समझ आ गया, दूसरा नहीं आया.
You see, when you calculated the moment of that bucket, you only included the water and the empty bucket. But you are also lifting the rope. In that calculation, you have not calculated the rope. The rope is also might be heavy.
Okay.
Do you understand what I'm saying?
Yes.
You only calculated the weight of the water and the bucket, but with the water and the bucket, there is a rope also, which you are lifting upward. You have not calculated, you have not considered its weight. Understand? Another, the third point is that the force, the third point, the force you applied may be not perpendicular to the radius. Okay, if the force you apply on something which is rotating, if you do not apply the force perpendicular to that thing, to the radius, what happens? The moment arm becomes smaller. If the moment arm becomes smaller, you have to apply a larger force. If the line of action of your force is not perpendicular to the radius, then the moment arm becomes smaller and you have to apply a larger force to produce the same moment. The fourth point which is mentioned here, the rope is winding around that drum. When one layer of the rope is wound around the drum, you see the moment arm on that side will become larger. So that side will have a larger moment. When it will have a larger moment, you will also have to produce the larger moment. When the rope,
Next.
do you understand this point, the rope point? When the
Yes.
rope has wrapped around, one layer of the rope is wrapped, you understand the radius of that thing will become larger. The distance between the bucket and the center of that cylinder will become larger. The moment arm will become larger. That means it will have more turning effect. That bucket will have more turning effect. And to balance that, you will have to provide more turning effect. You understand?
Yes.
Okay. Just two parts. And then we will go on a break. Okay. What happened here? We're done with the D first part. Second part. State the energy changes that are taking place as the bucket is being lifted at a constant speed. Whenever you are moving at constant speed, you will only mention the heat which is produced. Okay? So, because the object is moving at a constant speed, so what will happen? The chemical potential, because the thing is rotated by the man. So that man has a chemical, the energy which the man has, that is chemical potential energy. And that is ultimately converted into heat energy. Don't say it is converted into. Another thing can be said, because the bucket is lifted upward, it is gaining gravitational potential energy. And so it means the chemical potential energy is converted into the gravitational potential energy of the bucket, and it is also converted into heat. Okay, it's a 3-mark question, you see, and you only have to state to see what does this say. Let me read this. From chemical energy or chemical energy at the first. So that is one number for saying that the man has the chemical potential energy. The second number is for saying that the gravitational potential energy or to a thermal heat energy at last. To thermal and internal and heat and thermal internal energy. So you see, you say two things. One, the chemical potential energy of the man is converted in is used to increase the gravitational potential energy of the bucket, plus that energy is also converted into heat. That's it. Okay, it's a 3-mark question.
Next.
You are done with this thing. So we are on the uh, state. What can be deduced about the force acting on the bucket when it is traveling upwards at a constant speed?
Forces are balanced.
Because it's moving with the constant speed, so it means that the downward and upward forces, they are balanced. So the tension in the rope and the downward weight, they are balanced with each other. It's a 1-mark question only. No resultant force or force is balanced. Cancel, or tension equals weight of the bucket, or upward force equals downward force. Okay. So what you wrote?
Resultant force is zero.
The downward and upward force are equal, and the resultant force will be zero. Okay. So we are going on a break of 15 minutes. So we will be back at 10:30.
Okay.
ठीक है.
Okay. This call is on. Don't go away from this call. Okay. Just take a break. I will switch off the recording. Okay. So this was the first part of our lesson today. We will start the recording again. I'm just switching off the recording. So thank you very much, everybody. We are going on a break. So after 30 minutes, we'll be back. Have a good day.